In this video, we look at the concept of data types and casting. So you should already be familiar with the concept of a variable or a constant, an area in memory that you can set aside in your program with a given name, which can hold some data, which you can then refer to in your program. These variables and constants can have a number of different data types, and the ones you need to know about for your exams are integers, reals and floats, characters, strings and booleans. On the table in the top right, we'll see the standard generic names for these, and that's how people commonly refer to them. And then you'll see how they're actually referred in the PLS. In other words, how you actually use them in Python. So integers is the word int, and that's all lowercase note. Reals are floats in Python, and that's a small f. Booleans are bool, B-O-O-L, and characters and strings are all referred to by str. It's important to understand that each data type uses a different amount of memory, and therefore to optimize the program, you should try and use the correct data type at all times. For example, as we can see by this illustration, there's little point in storing the whole integer number 22 in a real or float data type, when the integer data type is perfectly capable of storing it and takes up less memory. We're going to use the analogy here of a beat the dice program, which we've been looking at in a couple of videos to talk about another concept. So with beat the dice, a player rolls 2 dice. The order of the dice is determined by the value, and the highest value comes first. So if a 4 and a 6 was rolled, the result would be 64, not 10, 64. We're using two variables here called dice1 and dice2, and we can see them there, and we've declared them and we've assigned them the values 0. We know that our dice1 and dice2 variables are only going to ever hold the whole numbers 1 through 6, because these are the numbers that appear on the faces of a dice, and therefore the variables dice1 and dice2 are stored as integer data types, as integers can only hold whole numbers. Later on in our code, you can see we then compare the numbers, and depending which is greater, we join them together. Now, in order to concatenate them, join them together, and simply not add them as you would with maths, we need to store them as strings. So if dice1 equals 8 and dice2 equals 5, if they were stored as integers, the result will be 13, because the integer 8 plus the integer 5 is 13. If they're stored as strings, then dice1 plus dice2 is 85, because 8 concatenated with 5 is 85. So we have a need here to cast or convert one data type to another. And we do that with the str command, which converts a data type into a string. And we're able to convert from pretty much any data type to any other data type. It is easy to convert string data types back into integers, or indeed to other data types like I've just said, so we can perform arithmetic operations on their values. We quite often ask the user to enter numbers via the keyboard, but any value entered from the keyboard is inputted as characters, even if we often want them stored internally as numbers. So when someone presses 6 on the keyboard, they are not entering the number 6, they're entering the ASCII character 6. So it's quite common to cast or convert them into integers. So here we have a line of code, choice equals int, input, enter your choice. That's taking an input from the user, they press a key on their keyboard, and the result of that key is then cast or converted into an integer data type. So just a quick recap then. Variables and constants can hold integers, that's whole numbers, positive or negative. Reals or floats, that's numbers with a decimal part. Characters, that's a single alphanumeric character. Strings, a set of characters. Or booleans, which are true or false and often called flags. We typically use these to track if something has happened or not. Changing a data type from one type to another is known as casting, and casting is necessary so that sub-problems receive data in the format that they are expecting. Casting allows numbers to be manipulated as strings, and casting allows inputs that are always strings to become numbers. So one other thing you have to be able to do under exam conditions is to be able to select suitable data types based on a given scenario. So here's a typical example you might see in an exam. A program is to be written which asks a user's name, age and telephone number. If they are aged 17 or under, it informs them they are not eligible to vote as they're too young. If they're 18 or over, it stores their details and tells them they are eligible to vote. So the first thing you have to do is study the scenario and work out all the variables that you would need. Well, the program is asking the user for their name, their age and their telephone number, so it seems sensible that these need to be variables, and I've called them name, age and telephone number. But it's also storing their eligibility to vote, so I've got one more variable called vote. So you can see I've listed those down the left hand side, and each of those variables now needs to be assigned a data type. So are those variables going to hold a string, an integer, a real or a boolean? Why don't you pause the video and see if you can have a go yourself, and then unpause it and see if you got it right. So there's the answer. Vote should clearly be a boolean because it's either going to be storing true or false. They are eligible to vote or they're not. Name is clearly going to be a string as it's a series of alphanumeric characters, and age is going to be an integer, presuming they enter their age as a whole number. Finally, telephone number should be a string. Now let's just talk about that last one for a quick second. Many students often choose integer in the exams when they see telephone number. Oh yeah, telephone number's it's a string of numbers. I'll store that as an integer. Telephone numbers don't have fractional decimal points. But that is wrong and it often catches people out. Can you explain why telephone number must be stored as a string? Well, the answer comes down to the nature of a telephone number. Most telephone numbers start with 0. For example here, 07548 433 844. If you asked the computer to store that as an integer, it would lop off the leading 0. And of course this would no longer be a valid telephone number. Numbers also are often entered as telephone numbers with symbols. So people will sometimes go brackets 07548 brackets 433-844. And of course again, integers only support whole numbers. So this is why telephone numbers should always be stored as strings. So that's the theory content of the video covered. We're just going to spend a little bit of time talking about the programming language subset. If you've heard this before, you can skip the rest of this video. Otherwise, it's definitely worth a quick watch. So the exam board at EDEXCEL have released a document that they call the Programming Language Subset, which you can see here on the right. This document specifies which parts of Python 3 are required in order that the assessment can be undertaken with confidence. Students familiar with everything in this document will be able to access all parts of the Paper 2 on-screen assessment. The exam board will not go beyond the scope of this document when setting you any questions in the Paper 2 exam. Any students who do successfully use more complex methods, which are not included in the document, will still, however, be awarded marks. Further to this, you will see here from the front of the exam paper that you are actually going to be supplied with a printed and an electronic copy of the PLS during your Paper 2 exam. Well, if this document outlines everything you need to know in order to program in Python during the exam, and you can be guaranteed that you can answer all the questions using all the techniques in this document for full marks, then you might as well get used to using it now. Ask for a copy from your teacher and have it as a reference guide at all times throughout your GCSE course. It will be invaluable.